We're going to pick up today right where we left off with the last video on prisms. We're going to pick up with cylinders today. And you'll be able to see real quick how closely they are related to prisms, and hopefully this will go pretty smoothly. So that's our objective: find the lateral area, total area, and volume of a right cylinder. So there's the definition of what a cylinder is: a solid with congruent circular bases in a pair of parallel planes. So with circular bases, back yesterday when we talked about the prisms, they were rectangles or squares. So now they're circular. So just as we named the prisms based off the bases, called them rectangular prisms or square prisms, now we're going to call another way to talk about a cylinder would be to call it a circular prism. So the same thing, but it's got a special name, and we call it a cylinder. So a cylinder is similar to prisms. They're circles, not polygons. That means it's not a polyhedron, but that doesn't affect a whole lot for us. The axis is the endpoints that are at the center of the circular bases. If the axis is the altitude, then it's a right cylinder. We're only going to deal with right cylinders. So here's a picture of what a right cylinder is. So you can see there we have the base on top and the base below, and then we also have the axis. When it's an altitude, that's considered a right cylinder. Another important part for us today is going to be the radius, because that's going to help us find the area of the base, which is again the same from yesterday. So the radius is going to become a part of the key information for us. The segment joining the centers of the bases are the height. The radius of the base is also the radius of the cylinder. So again, I'm talking about the radius of the base and of the cylinder. The formulas from yesterday, they're exactly the same as they were before. So lateral area equals perimeter times height. Total area equals lateral area plus 2 times the area of the base. Volume equals the area of the base times the height. So the difference being, now that we're dealing with a circle, the perimeter is the same as circumference. We spent a lot of time with circles earlier in the last few weeks, and so you guys should be familiar with what we have here with the circumference formula. And the area of the base is pi r squared. So those again should be familiar to you as we move along. But there's a reminder for you. So these are the same as yesterday. So same as prisms. And then these are familiar to us from our circle chapter. So moving on. Again, should go pretty quickly. I want to find the lateral area, total area, and volume of this right cylinder. So just like yesterday, we have our key information. And like I told you, we're going to add to that. So here's our key info. That was the perimeter of the base, the area of the base, the height of the I'm going to switch these around. We'll say the height of the prism, the area of the base, big B, and again, I'm going to add the radius to this key information. So some of this information is already given to us. The radius is 5 centimeters. That's good. The height of the prism is 8 centimeters. So we need the perimeter of the base and the area of the base. Again, this is the same formulas we're going to use from the previous slide. So we'll go ahead and do it up here. The perimeter, which is the same as circumference, which equals 2 times pi times r. And we're going to leave r in our answer. So this is going to equal 2 times pi times the radius, which is 5. And just like before where we left pi in our answer, we want to leave pi in our answer here. 2 times 5 is 10 pi. So our perimeter is 10 pi centimeters. And lastly, we need the area of the base. Pi times r squared. This equals pi times 5 squared. And that equals 25 pi centimeters squared. Make sure to watch your units on that. That's area, so it has to be units squared. In this case, centimeters squared. So for us now, we can get into finding the lateral area, the total area, and the volume of this right cylinder. Again, we're going to leave pi in all of our answers. So lateral area equals perimeter times the height, and there's your refresher on those. So the perimeter is 10 pi, the height is 8, so that is going to equal 80 pi centimeters squared. Again, area is squared. Let's go to total area now, equals LA plus 2 times the area of the base. Lateral area is 80 pi, plus 2 times the area of the base is 25 pi. So this equals 80 pi plus 2 times 25 is 50 pi. 80 pi and 50 pi using your calculator is going to be 130 pi centimeters squared. So once again, that's centimeters squared because we're talking about area. And then last is, let's talk about the volume. Volume equals area of the base times the height, which equals 25 pi times 8. 25 pi times 8 is 200 pi. And remember, this is new from yesterday. This is going to be units, or centimeters cubed. So again, our answers here are going to be 200 centimeters cubed for the volume, 130 pi centimeters squared for the total area, 80 pi centimeters squared for the lateral area. Moving forward, same type of thing. Just as before, let's do a lateral area, total area, and volume of this prism. And we'll put our key information right up here. And again, just as before, it's just from yesterday. We have the perimeter of the base, we have the height of the prism, the area of the base, and again, new for today is the radius. So let's start with the radius, 1.2 meters. The height of the prism, 8.3 meters. So perimeter of the base, 2 times pi times 1.2. 2 times 1.2 using your calculator is 2.4 pi. So again, our perimeter is 2.4 pi meters. And then the area of the base, pi times r squared, 1.2 squared. So again, make sure you use your calculator on this. 1.2 times 1.2 gives you, of course, 1.44 pi. This is meters squared. So again, there's our key information. Real quick with our lateral area, perimeter times the height, 2.4 pi times 8.3. Again, we're leaving pi in our answer, so we're not worried about multiplying that by the 3.14, which we sometimes have done for pi. So 2.4 pi times 8.3 is 19.92 pi meters squared. Let's do the total area. 19.92 pi, which is the lateral area, plus 2 times the area of the base. 2 times the area of the base is 2 times 1.44 pi. So multiplying those together, or multiplying that together and then adding, so I get 19.92 pi plus 2.88 pi, and then that's going to equal 22.8 pi. Again, this is area, meters squared. So last but not least, we'll get into the volume. Volume equals area of the base, 1.44 pi, times the height, 8.3. So again, not worrying about the pi, and we're going to get 11.952 pi meters cubed. Again, there's the difference being volume. It's not squared this time. So let's look at this now. We're given the lateral area and the height. I want to find the radius and the total area and the volume. So again, our formula for lateral area is this. Lateral area equals perimeter times the height. If I have the height, let's play everything that we have. We have the lateral area, we have the height. So I'm going to get 96 pi equals perimeter times 12. If I solve this for the perimeter, I'm going to divide 96 by 12. So divide by 12, divide by 12. So I get the perimeter equals 8 pi. So I find the total area and volume. That's going to help me out with the perimeter now. Again, part of the key information is the radius. So again, let's think about perimeter for a second. Perimeter equals circumference, which equals 2 times pi times r. So 2 pi r equals 8 pi. I want to solve this for r to find the radius. Divide by 2 pi, divide by 2 pi. Those all cancel out. I get the radius. The pi's cancel out. 8 divided by 2 is 4. So the radius is 4. Let's add area to base here. Pi times 4 squared, which is 16 pi. Now that I have the area to base, now I can find the total area. Total area, let's do it over here. Total area equals lateral area, that was given to us, 96 pi, plus 2 times the area to base, 16 pi. 96 pi plus 32 pi. 96 plus 32 ends up being 128 pi, which is inches squared. With the volume now, area to base, 16 pi, times the height's given to us here. So I get, end up having 16 pi times 12, and you can, using your calculator as always, multiply that out, you get 192 pi. This is volume now, inches cubed. One last one, this is the volume this time. So we just found the volume on that previous example. We'll use the same type of thing. So volume equals area to base times the height. Well, again, 245 pi equals area to base times 5. So divide 245 by 5. Those cancel. 245 by 5 is 49 pi equals the area of the base. Again, our key here is finding the radius. So let's go over here real quick and do area of the base equals pi r squared. 49 pi equals pi r squared. The pi's cancel out from each side, so I have r squared equals 49. Take the square root, r equals 7. So my radius is 7. So we need the lateral area and the total area. So in addition to this, in the radius, we need the circumference or the perimeter. 2 times pi times 7. 2 times 7 is 14 pi. That's meters. Total area, we need the area of the base. Area of the base equals pi r squared equals 49 pi. And looking back at our work, we already had that right there. We didn't even necessarily need to do it again. So now that I have the perimeter and the area of the base, let's go ahead and find the lateral area. Perimeter, 14 pi, times the height given right here, 5. So that equals 70 pi meters squared. And lastly, total area equals 70 pi, lateral area, plus 2 times the area of the base, 49 pi. 70 pi plus 98 pi, that equals 168 pi, and this is all meters squared. So that wraps up cylinders for us. Again, cylinders are very, very similar to the prisms. Think of them as circular prisms because, of course, they have same properties, same formulas as the prisms, just with circular bases.